So my name is Dragan Gajic. I work as a software architect here in Novi Sad in company Levi 9. You see our logo there. So this talk will be about enterprise integration patterns and the way Spring guys implement that. So let's start. First, why do we need to integrate at all? So would be nice, so we build one monolith application which covers all our needs. Well, that's nice, but I guess it's not possible, right? The first reason would be that, enterprise systems are not made at once. So usually application landscape, if you look in one organization, is evolving during the time. The second reason, you don't develop everything by yourself, right? So there are third-party services, third-party system, and of course, in the age of internet, you need to integrate with external services as well. So, and when we talk about integration, it's not only about exchanging data, it's also integrating on the level of processes. If you look web services and these kind of technologies, this is about not only integrating data, it's also integrating and using some of the functions they provide. So what is hard with the integration? Well, first, you do it over network. And networks are unreliable and slow. When I say slow, they are slow comparing to static or dynamic linking on the same machine within the same process or JVM. So, of course, if you have external system, they are not probably built using the same technology. So that's the other challenge you need to cope with. Changes, of course. So it's not one system. You need to change pieces, and then you need to assure that everything works together as it worked. With the third-party services, you do have limited control, right? It's external system. You cannot change in order to adjust to what you need. Standards, well, the thing with standards is we don't have them, actually. The only standard which is there is XML, but XML does not have semantic, right? So it's about the format. And of course, all these things are not easy to maintain. So if you have multiple systems, you need to assure that they all work. So how we cope with that? What are the integration styles we use? First one is the file transfer, right? So if you have two apps, and then you need to exchange some data, you will do it over the file. So they need to agree about the format and location, and then one application can export data, the other one will import. If you need to do sort of transformation, you have ETL tools. What's the issue with this approach? Well, you can easily end up with synchronization issues, So you cannot exchange files all the time. So you can have delay in synchronization, which is, for some system is okay, but for some is not. So what is else there? Well, so common pattern I see, it's shared database. So how it becomes, you have relational database, one application, then you build another one. Typically, you have UI, where you change some configuration, and then you have some background processes and write into some tables which read, scan for changes, and then do some processing, okay? That's a typical case where you integrate on the database. Well, what is the problem with database? Encapsulation is on the level, well, there is no encapsulation because you store data, raw data. The other thing is, what is good format for one application is probably not for other one, okay? The third thing is RMI or RPC, remote method invocation. So this is, let's say, the whole philosophy is that you make remote calls as local ones. So, for example, if you recall some frameworks for web services in Java, Axis, Apache CXF, what they do, you provide WSDL file and then they generate stubs, client code. And then you use that client code and you have impression that you are making local calls while that client library is doing all that remote calling. Well, the thing is, local and remote calls are not the same. You know, local calls are usually reliable. Either it's static linking calling function within the same process, within the same JVM. So that usually works, you know. But when you have network, it's first is slower. What you will do if the web service is not responding? You know, you need to handle that. So these are all the things, you know, you write your business logic and then you need to cope with all consequences of the choice. So that's not good. The next approach is messaging. So if we compare, there is nice example of difference between RMI and messaging. So RMI is, for example, web services. So it's like difference between a telephone call and voicemail. So if you want to exchange information with somebody over phone, when you call him, he must be available. He needs to answer, okay? So similar like with the web service. If you want to call web service needs to be online. So your third-party system needs to be online and need to respond, okay? With messaging is like with voicemail. If nobody is responding, you can leave message on some storage, and when that person is available, it will be able to use that information. So that's essentially difference between messaging and RMI. So what are the main, let's say, characteristic of messaging? So this was example of asynchronous exchange of information. So it's web services are always in sync. You can use messaging middlewares or other technologies to pass messages, and they offer you reliability, okay? And the whole idea when you create systems is that you achieve loose coupling between of the pieces, you know. And with messaging, you do that in 3 different areas. So you decouple sender and the receiver using common format. There are ways so you achieve location transparency. So you don't need to know where your receiver is, you know. You just pass message to some infrastructure and it will deliver. With web services, you need to know IP address or host name of the service, right? So if you move it, you need to change it. That way it's coupled. And also, this readiness is also important. Okay, so you can, for example, if you have 2 systems and you want to change one to deploy a new version, you don't need to stop the whole system. Okay. So let's see what are the basic concepts in messaging. So from all these 4 integration styles, I'll be talking about messaging. So let's see what is in there. Well, 2 simple concepts, message and channel. Okay, so message is something which has headers and payload. So you use headers to put some information about the payload, about the data you transfer. Okay, and channel is used to decouple producer and consumer, or sender and receiver, okay, in order to achieve loose coupling. There are basically 2 big groups of channels. One is point-to-point, and the other one is publish-subscribe. So they say they have point-to-point semantic or publish-subscribe semantic. Publish subscribe is actually broadcasting. So if you have a channel and you have multiple subscribers, message you put into a channel will be received by all subscribers. Point to point is you can also have multiple receivers, but only one get the message. Okay? Now, this model is simple, and simple is good, especially in IT, but it's too simple. So what's the issue? So if you need, so one system is sending a message using the model or the business model it has, and the other one is receiving. But you need to, let's say, transform that message somewhere, okay? Because otherwise you introduce coupling, and we didn't do anything. So where you can do? Well, you can do it on the producer or consumer side, but again, that is coupling. Producer needs to know something about the consumer. So we need to do some sort of processing with messages somewhere or somehow in a way that either producer or consumer are not aware of each other. So there is one general architectural principle which is called pipes and filters. It is not exclusively related to messaging, but it nicely fits to messaging. So what is pipes and filters architectural style? When we have a problem to categorize something, we then call it style, like with REST. It is not standard, it's architectural style. The same with this. So it is a bit broader than design pattern, so we call it style. So it's made to divide complex processing in a way that you have pipes and filters. Pipes are used to transfer messages between filters, and filters will do something with the message. For example, transform. I have an example here I will use later with a user registration on the website. So you will first persist when somebody fills in the registration form. You will persist. You'll probably send validation email so you can check email address, and you will send it. And these are all steps. And you can look at that as a process using pipes and filters. How that fits into messaging? Well, really one-to-one. You can look at the pipe as a channel and filter as endpoint. Endpoint is a component on each two, let's say, sides of the channel. And we'll see through examples how we form processing using this style. So please note, and this is a bit confusing, this is happening somewhere, you know? So in this architectural style, the pipe or channel can be in the same process like running application. But the trick is that it is decoupled, you know? Application is not aware it is connecting to something which is doing pipes and channeling. So you will see that through example. Okay, and the examples I want to show you are actually really concrete ones. So this was theoretical introduction, but I intend to show you how it works using Spring integration. So how many of you are using Spring Framework? Okay, that's nice. So Spring integration is one of the top level projects in Spring IO platform. They renamed it recently, so now it's called Spring IO platform. And it is made to enable lightweight messaging. Of course, when we talk about Spring Framework, we always use lightweight, non-invasive, and this kind of terminology. So in which way? So it combines dependency injections, POJOs, and messaging. So in Spring, everything is about POJO, plain old Java object. Well, would it be nice that that POJO can be somehow, without we doing anything, transferred to a message. Well, that's exactly what Spring Integration is doing. They also implement most of the enterprise integration patterns. So if we talk about integration, there are about, I think, 65 patterns you can use. I'll show you between 10 and 15. I didn't count it because there are many of them. But in Spring Integration, they implemented most of them. Okay? So, and also in Spring Integration, there are a lot of integration or channel adapters with other systems. So what is channel adapter? Channel adapter is something which connects external system to your messaging system. External system can be your application, third-party system. For example, we'll here use email channel adapter to send email. We'll use RabbitMQ channel adapter to pass message to RabbitMQ. But there are many of them. So SVTP, FTP, integration with Facebook, Twitter, whatever you name it, it's probably in there. And the last but not the least important thing to understand, Spring Integration is programming framework, so programming model. It is not messaging-oriented middleware like RabbitMQ, JMS, ActiveMQ, which is a JMS provider. It is not ESB like Mule. So it has abstraction of channel, but that's just, it is just abstraction. So if you really want to exchange data between two systems, you will need to use some infrastructure for it. You will not find it in Spring Integration, like you have it in Mule or Service Mix or Fuse, okay? So this is like Apache Camel. It's a programming framework for messaging, okay? And you will see shortly on examples what does it mean. So in order to illustrate these design patterns, I will use one example. It's user registration, like I mentioned. And usually when you register some website, they will like to validate your email address by sending confirmation email, where you have some random link on which when you click, you will look into your inbox, and when you click, it will verify your email address. So why this example is, I believe, good to illustrate how messaging works. So when you start to code, either through REST API, through some MVC framework, so you will have a form or REST call, you will do some validation, you will persist the profile, okay? And then you need to send an email. And you need to do that asynchronously. Why? Because you don't want user to wait. And now, when you need to do it asynchronously, that in Java usually involves threads. So you need to create thread, run separate thread, watch for its execution, and all kind of things which are not really related to the business logic, to validation. And this is something we always try to avoid. Okay, our code should reflect the business logic. Okay, you also need to generate user ID, to store somewhere a link between user ID and I'm using UUID for that random string, okay? And to be more interesting, let's imagine that on our website, there is also one more application, back office or admin app, where you have some admin sitting and moderating your profile. So when you register, somebody will need to take a look on the pictures you have uploaded. Are they decent or so? So you need to notify that system that there is a new user in the system. So in that shared database model, you will usually put a flag. So it is new, and then you will have some background process scanning that table and looking for that, for the records which have that flag, and then notify system, like you will do pooling, Okay, in this case we'll do a bit different. So first thing we need to do is to connect our application with the messaging, okay, in a way that application is not actually aware of it. So we don't import any client libraries, or we do not make dependencies to a messaging system. And there are a number of ways to do that, but I really like one. So do you know that in Spring integration there is internal message bus, event bus it's using? Have you used that? So you can fire events from different parts of Spring integration and then create listeners to consume these events. So I'll use that. So I guess you saw this. It's one method in my REST controller, which will be called, I have mapping, I'll get some registration resource, I'll save it, and then I'll just publish event that there is a new user. This new registration event is just the class which wraps my profile, nothing more. So it's kind of POJO, okay? How I'll get publisher? Well, in Spring, if you implement application publisher aware interface, the Spring will inject this publisher, okay? So you just, when you write controller, put it implements application event aware interface and just auto-wire publisher. And this is how you can publish events. So this is all Spring related, nothing related to the messaging actually, okay? And this is the first pattern I want to show you. It's called channel adapter. And as I said, it's used to put or consume message in or out of your messaging. So this is your application, this is your channel adapter, and as a result, you have a message in some channel. Okay? And again, when we talk about Spring integration, we talk about pipes and filters. Later on, we'll see how to pass that message to other application. But this is that architectural style I was talking about. So Spring integration is programming model, so it offers us abstractions we need. And this is how you describe that in Spring integration. So I'll use XML as DSL for Spring integration. There is also Java, Groovy, Scala DSL for this. But I really, for this one, I like XML. I'll show you later. If you use STS, it can visualize all that. So I'll show you in Eclipse. So what we have here, we have a namespace. We have inbound channel adapter. So this is special channel adapter, which will listen for those events. Okay? And I can even define the type of event I want to capture. Okay? So from my code, when I fire that event, it will be taken by this channel adapter and put it into event channel. So the message will actually wrap this registration event object. That will be payload of the message. And what is channel? Well, it is like this. So this is the channel in Spring integration. So there are 5 or 6 types of the channel. This is direct channel, and it has point-to-point semantics. So this message can be consumed only by one consumer. Okay? Now, if you remember of the example, I need to create UUID. Okay? So for that, I'll use another design pattern, which is called content enricher, and it can be used to enrich payload or header of your message. Okay? So this is not channel adapter. So all other components have input and output channel. So my input channel is event channel, where I will receive registration event. And then I'm using here in expression, I'm using a bit of spell. Spell is Spring expression language. So where I call this static method random UUID to string, and this will generate UUID and put it in this header. Okay, so my message now has a payload, which is registration event, which wraps my profile, and one header, UUID. Okay, and if I want to see what is happening in channels, what kind of messages are passing through channels, I can use another design pattern, which is called wiretap. So with wiretap, I can effectively copy every message which goes to destination to some other channel. In this case, I'm using logger. So this way I can debug what messages are passing through my messaging system. Okay, and this is example of global wiretap, which debug messages in all channels. But I can do it for one channel if I want. So let's put all together. So what we have, inbound channel adapter, which connects my application to a messaging, to a channel. There is a header enricher, which will generate UUID, and I will just log for now, because I'm missing other parts of the system. So I'm using something called login channel adapter. Okay, this is actually adapter which can connect for log4j or CLF4j to your logging system. If you look at in XML DSL, so I just wired all components with channels. So for inbound channel adapter, message will go to event channel, enricher will use event channel as input, and it will output message to logger. So my message will be enriched with the UUID. Okay, so now I have my UUID, and when I have that, I want to do two things. I want to persist link between user ID and UUID, so when user clicks on that link, I can find the user by user ID, and I also want to send email. And I want to do that in parallel, okay? So there are also many ways to do that, but I want to show you one pattern, which is called composite processor. So I use it for here. So what we are doing, first we have a splitter, because for storing link between UUID and user ID, I just actually need user ID. UUID is in the header. But for creating an email message, I need the whole profile. So what I will do, from my message, I will create two messages, okay? Then I need to decide, I need to split processing. For that, we can use router. And there are many types of routers, but I will use a router which is looking at the payload type. So if it is long, which is user ID, go to this channel. If it is profile, go to other one. And then I will do some processing, and with aggregator, I will wait those two processing steps to finish, because remember, this is asynchronous. And then I will pass some new message to the rest. So let's see how that looks like. So on the left, you have a splitter, you have a message, and then you have sequence of new messages which have different payload. How we actually do that in XML DSL? Well, we have an input channel, output channel, method, and some class which is splitting message. How that method looks like? Well, it's really simple. It will split my registration event. Spring is clever enough, so if in this method you use payload, it will extract payload from the message. You can easily, if you need headers, you can put here message, and then you will get the whole message. And what it's doing is just creating array of ID and the whole profile. That will go to router, and look, router how behaves. It has two mappings per type. So if it is long, go to save channel. If it is profile, go to email channel, okay? And now, with saving, I want just to call some Spring Bean, some service. How I do that? Well, I use service activator pattern, and look, I just put @ and it will find profile service in the application context. You see how it's easily integrated with the Spring and core container. So I just need to call, and I can use this spell headers.uid to get my header, custom header, and the payload. Payload is a profile, okay? And let's look how this method in my profile service looks like. Well, it will receive string, which is headers UUID, and it will receive ID. Yeah, that it's not a profile, I am sending ID. And it will just, I use in-memory implementation, so this is just a hash map. I will put connection between user ID and ID. Okay? And how will I actually send an email? Well, there is a special support for emails in the email mail space. So if I set certain headers, then I can pass that message to the mail outbound channel. So I set header from to subject, okay? And I will use transformer, which is another pattern. You see it, which is called translator, but in Spring it's called transformer, which transforms the message. And I'm using, again, spell to create some string, okay? And this is how I create the content of the message, okay? So message which comes out from this is actually string with some headers from, to, and so on. Then I need to wait for both of them to finish and to aggregate in some message which I will pass further. And in this case, it's not really important. I just need a profile. So in other cases, you can aggregate results of both steps in a new message, in a new structure. So for that, I use aggregator. And aggregator consumes, so I don't know, have you noticed, but both service activator and this chain output channel is done, actually. So they both put results in this common channel, okay? I didn't say, but this chain, actually, if you notice, between every filter, you need to create a new channel. If you have some sequence, you know, then you can use chain and avoid that defining channel. So if you put something in a chain, output of the first one of this header enricher will go to transformer. So that's just easy way to avoid creating many channels. So this is aggregator. Again, method is really simple. It receives a list of messages, and this is a bit Java 8 streaming API. So as a result, we will use string. And that string goes to the mail outbound channel. And this is how we actually send an email. We use outbound channel adapter. We just define host and port. So again, I'm using Spring support for loading properties. So this is in some property file, host and port. And this thing will send email. This thing will talk with SMTP via SMTP protocol and it will convert those headers and content to something which is according to SMTP protocol. And this last being stored, because aggregator needs to wait, and you don't know how long processing will take, you need to store somewhere link. How, by default, it will put when it's splitting a message, it will, in the header, special header, it will put the same reference. And then it will wait for message with that reference, so it can call this method to aggregate. And you need to store that somewhere. So we use simple message store, which is actually in-memory store, but you can persist that if you want to have reliability. Okay. So far, if you remember my example, we managed to send email. That's this on the left. We also now want to notify other application, okay? So again, we have two separate flows. But for this one, I will actually replace my input channel and use publisher subscriber channel. So I will have a channel which have two subscribers, one to sending email, the second one to notify other system. Okay? And that other flow of notifying other system will use RabbitMQ to pass the message. Okay? So if I look this admin flow, I will have channel, which is downstairs, transformers, transformer. Why? Just to extract ID. Okay? I just need to pass ID of the new user to admin system. Why? It's going over wire. I don't want to send the whole object. Okay? Channel, outbound channel adapter, RabbitMQ, and then this application will have inbound channel adapter to receive that message, and I'll just log it. I'll not do anything with it. Okay, so everything connected looks like this, but I will show you now in Eclipse. Just a second. Okay, so I have two projects, one for which is REST API for registration and one which is admin. So have you heard about Spring Boot project? Is anybody using it? Okay, so this is really nice project which allows me to write nice examples really quickly. So this is my application. So I just import two XMLs, and of course the application is typical, let's say, Spring integration. I have my controller which monitor this URL services, and this here is my method. This one save. Here I show you. So nothing really special about that. It's just a Spring MVC REST app. Okay, and this is my publishing, and this is how I just implement this interface, and Spring will inject this for me, so I can publish events. Okay, let's look now for the, now everything for the, okay. Let's look now for the integration config. So it contains everything I show in the pieces. So it's just one context file with some namespaces from Spring integration. And this is what I wanted to show you. So this channel is not anymore channel, it's publish subscribe channel. So this is the only thing I needed to change, okay? So all components which actually use that as an input channel will be subscribers. So you don't need to say, for this channel, these are the subscribers, which is really cool. You just put some component, some endpoint, and tell input channel is that channel, and it will be subscriber. So this is actually creation of an email, okay? And this is that part which sends a message to RabbitMQ. So note this input channel is event channel, and this is just some RabbitMQ stuff, connection factory and all kind of other things. So this is one application. Let's take a look for another one, which is also really simple app. Again, Spring Boot to load the context. And here I just have inbound channel adapter and logger, and also RabbitMQ stuff. So this is a client which will consume that notification. There is a new user. So let me just quickly start this. I will use fake SMTP, okay, to receive email. In the unit test, I used Visor, so you can use that as well, but it's more handy for this. And I'll first start my REST API. And look how simple is it. I just run it as a Spring Boot application. It will actually start servlet container, deploy everything, and it will listen on 8080 port. So let's look. This is RabbitMQ management console. Here is my queue, no messages here. So if I go to the REST client and do some post with some payload, here is the message, here is the email. So you can look how it looks like. Okay, but I didn't start the client, the admin UI. Okay, so if I look for the message, it's here in the queue, waiting to be consumed. Okay, so if I look at it, it's here. By default, RabbitMQ will use Java serialization, but you can easily switch to JSON to serialize that object in order to send it over wire. Okay, why? Because on the other side, it might not be Java, so it might be some other technology. So if I now start admin app, the same way, just run as Spring Boot app. And I'm using a logger. Here is my message. So actually the content is 1, because my user has ID 1, and ID is the only thing I wanted to transfer. So this is another application which connects to that queue. So if I look now at the queue, no messages, so message is consumed, okay? So this is really important because, you know, with this, everybody are talking about microservices these days. So with Spring integration, RabbitMQ or some other messaging middleware, you can actually implement that, okay? So passing notification via messaging, and each of your microservices can have REST API, and they can synchronize using these events. And I guess that's all. This book is Bible for like on the level of elements of reusable code or Gang of 4 book. So this is the book for the integration. You can look of course, Spring website. Spring has really good documentation. So this book, it's a big book, so you will read a bit and then look for examples. These samples I showed you, you can find on Levi9 GitLab. So it's publicly available. So everything I showed, the code, you can look here. And all these nice pictures are on the Commons Creative License, so I need to put this link here. So you can find the registry of design patterns, all 65 of them on this website. So I guess short Q&A session. Yep.
I have a question. I have actually 2 questions.
Okay.
Thanks. I actually have 2 questions. First of all, is there another way to define all the endpoints and channels rather than using XML? You said there was Scala. I don't know. Is there something like similar to Camel, like in Java, built in?
Yeah. So Camel is a similar stuff. So if you read over internet what are advantages, disadvantages of Camel over Spring integration, they will say Camel has better DSL. And but now in Spring integration, you can use Java config. This is something I didn't say, and you can use similar DSL. So with Java config in Java, you can use Groovy, Scala, instead of XML.
Okay.
So XML is only because all these nice pictures, it can, there is a, in STS, there is a visual designer, so you can nicely visualize that. So that is why I have used XML. Okay, second one.
The second question was, you haven't showed us how do you define the configuration for the endpoints. In example, we had here an MQ. We also had an email. For the email, I think I saw it in the configuration with the host and port.
Yeah.
And for the MQ, is it again in the XML?
Yeah. Yeah. This is for outbound channel adapter. So it's special namespace int mail. And I just need to define host and port. There are many other parameters, like credentials, if you need them, but this is my local SMTP, so I haven't defined them. And for the RabbitMQ, it's here. So you, again, oh. It's here. So again, just a second to duplicate. So again, you have int mqp namespace. Yeah, you have outbound channel adapter. You define exchange name, routing key, and this is Rabbit. This is from Spring MQP project. So if you use JMS, this part will be different, okay? I didn't show, there is also something they called channel backed by, so you can easily say this channel is actually RabbitMQ channel, so you skip all this part. But I wanted to use outbound channel adapter. So you can say this channel is actually RabbitMQ channel, okay? And then you can use Spring profiles to depending on the environment, to load different configurations. So that's really
that
nice.
was my question.
Yeah.
Thanks.
Yeah. So well, first, if you use STS, it will use namespace to check the validity of XML. You can use wiretap to debug, but debug what's happening in a channel. Well, it's open source. Yeah, maybe an Eclipse plugin will pull the factories which create objects, so you can plug in there. But as a way of debugging XML, it's, of course, it's not possible. Yeah, but you can use Java config. So I know in Java world, the last 2 years, they hate XML. We don't want to code in XML, but for this purpose, I actually think it's fine to use XML, DSL. Anybody else? Okay, that's it. Thank you. I will be around.